Okay, so we talked a little bit about zip files and that tar. What was that? Was it TAR and then the GZ? I think that was the way that was. So when you see a TAR.GZ, you have to double unzip that thing. And WinZip works. I cannot get, or 7-zip works. I cannot get WinZip to undo a tar ball. But I haven't tried WinZip in a couple years, so maybe that has been remedied as well. So the things that we're going to talk about is geoprocessing, and one of the aspects of geoprocessing is that through the process of geoprocessing, you create a new data layer. So if I were to create a subset, which means I select certain data and I export that, that's going to create a new layer. When you guys were looking at the quantitative data and you selected all of the forestry attributes, you could have exported that and had a separate layer of just forestry, okay? So with that ability to subset, you can take a really huge data set and you can simplify it for analysis in ways that kind of can clean up what you're working with. When you create a buffer also creates a new data set. And the nice thing about that is I haven't ruined my original, right? So I can create buffers of different sizes to kind of play with them and see what I want. Maybe I want to show that liquor stores influence schools and I try a half-mile buffer and that's not enough, so I really want to show that that's a problem, so now I'm going to try a mile buffer. So you can lie with your data. So all of these aspects will create, all of these geoprocessing tools will create new data. I'm going to skip this because there was a great video in the beginning of the year, which is really one of my favorite stories, is Dr. Snow. Did we do that in here? We didn't talk about, okay, so I get to do it. All right, so geoprocessing is part of this kind of more important aspect of GIS. It's not visualization, but it's the analysis of data, where location impacts what's happening on the landscape, either physically or culturally. And so we use geoprocessing and spatial analysis to make decisions. So Paula was talking about a project idea where she wants to look at aspect and slope and, was it amphibian? And say, you know, if we know where amphibians are in this certain area, and that's based on aspect and slope, then if I find aspect and slope similar somewhere else, I might be able to go look for amphibians. One of my students a couple years ago did a chanterelle map because she knew what were the criteria for finding chanterelles, and she looked at slope, elevation, the amount of oak. Is the oak the one? I think so. Anyway, and she was able to create this really cool map that she wouldn't leave with the class, apparently, because she wanted to have that to use for chanterelle hunting. So, you know, she said it was great. And I think I have a copy, but I told her I wouldn't share it. Anyway, Dr. Snow. John Snow was an anesthesiologist in the 1800s in London, in the Soho district. And there had been, outbreaks of cholera. And the theory at that time was that cholera came from bad air. It's called the miasma, something like that theory. And so what would happen when you had cholera is they would shut you up in your house, don't let you get near any washing because the cold water and cleaning yourself could expose you to more germs, and also shut all the windows. So one of the things he started to do was just trying to picture and understand the spatial dimension of cholera. And, who knows where he got that idea. But he began to notice that certain places in Soho, people were dying from cholera, and other places they weren't. So he started a dot map, and he was making a dot everywhere somebody died from cholera. And one of the things he noticed is that people who worked at the beer factory were not as susceptible to cholera. And he thought, well, that's weird. What's going on here? And apparently, if you work at the beer factory, you get a big jug of beer every day for lunch, right? The other thing he noticed that there was a concentration of cholera deaths around a certain water pump in the city. And while he didn't understand the bacterium, or I guess it's a bacteria, that causes cholera, he shut down that water pump, and the cholera epidemic was over. So this is kind of one of the first incidences of spatial analysis mapping that was used to solve a critical social problem. I just love that story. Okay, anyway, so when we do a subset, one of the ways that we do that is structured query language, or SQL, and we do that on one of the fields. So you would click the field state in your select by attributes. You would say, I want to query on the state field, and I want all of the state layer, and all of the populations that are greater than 100,000, right? So that would give you just the counties in Hawaii over 100,000. Or you could say, I want to find all the cities in the U.S. That are named Springfield. You could add an and the cities in the U.S. that have a population of over 50,000. So chances are all of the cities, I'm going to get more returns. Maybe there's 100 cities in the U.S. named Springfield, but maybe only 30 of them have a population of over 50,000. So with query languages, you can use these operators, right, of greater than, less than, equal to, in order to kind of get your subset. So one of the things you're going to do is, after you get all of your schools that are lane schools, you're going to select by type. And you're going to have to go through the data and find out what that type field means, because there is a categorical variable, 1, 2, 3, 4, and just 1 through 4. So you're going to have to look at the school names and try to make an association. And sadly, data is not clean, right? So there are some schools that are K through 3. There are some schools that are K through 9. Some are K through 6. So you're going to have to kind of go through that and make the best fit of which of these numbers actually represents at least most of the elementary schools, right? And you're going to select those. So this is an attribute query. Select by type is equal to 1. When you get down to the schools, you're going to do multiple queries. You're going to go through, out of the lane elementary schools, you want to find specific school names. So you're going to go school name equals Howard, or school name equals Maple, or school name equals Edison. Why am I using or instead of and?
Because if there's no school with all of those qualifiers.
That's right. Right, the and would be, if I used and, the program would be looking for a field that has the name Howard L, Maple L as one school name, right? The and means that that field has to have, or that record has to have both those things, right? So the or means I'll take this, or that, or that, or that, and you actually get all of them. And this just takes a little practice to kind of play with that and see where that works, what that looks like. So you're going to do an equals query, and then you're going to do an or query later. And then you're going to take those selected rows. Oh, and then you're going to do a spatial query. And actually, this is a little out of order, because the first thing you're going to do is a spatial query. If I want to find all of the liquor stores within 500, I'm really stuck on that today, 500 feet of a school, I would use a location. So I'm using two different layers. I'm not using the attributes within a layer. I'm using the whole layer. And I'm looking at the relationship between those two layers. So I'm looking at all of the school, all of the liquor store features, and all of the school store features. And I'm trying to find just those liquor stores that are close to a school. Maybe I want to look at highway impact on rivers, right? So I might want to find all of the rivers that intersect a road. If I want to find culverts, that's one of the things I would do. Or look at fish passage studies. I might try to find those things that actually cross. what you're going to do is find all of the schools that are inside Lane County, all right? You could also do this with a clip, right? You could take the Lane County feature and do a clip, a cookie cutter on the schools, but I want you to do this time with just a selection by location. And so that looks a little different. When you go up to the select feature at the top, you have to choose from the drop-down menu. Are you going to select by an attribute, or are you going to select from a location? And so for this one, I'm saying I want all of the schools, and then I want them the source layer, which within Lane County, and then I'm going to give a distance, right? Or I might want to choose within. So there's a lot of options in how you work that select by location tool. All right. Once I get my schools excuse me, select by location. So this one was this the rivers? Okay. Yeah, so here is a selection I did. I think children should have swim lessons, and maybe I think only those schools that are near rivers should have swim lessons. I don't know, I'm not very forward thinking. So here I'm going to do a select by location of all of the schools that are within, I think it was a quarter mile of some body of water, right? And so the blue dots are the schools that are selected. The red dots are the schools that did not meet my query, right? So now what I can do is I can export the blue dots, right? And I do a right-click my school layer, and I choose Data Export. And what that will do is just make a new feature with just those blue dots. So now I've created a subset. My data's gotten a lot smaller. One of the things just to kind of think about is that if I want equals, state equals Oregon, I'm going to just get that one record back. If I wanted to pick more than one state, I would have to say state equals Oregon, or state equals Washington, or state equals California. Right? The greater than is age. Greater than 40 means I'm going to get everybody over 40. Right? Less than, that's backwards. I thought I fixed that last year. Less than 40 means I'm going to get 39 and below. If I use the greater than and equal, that all's kind of like redundant math for you. Okay? So you can use all of those to kind of subset your data. They also have kind of, what I was talking about, the compound queries. So if I have two different fields, I've got an age field and an income field, and I want all of those records that are, let's say, states where the average age is greater than 40 and the average income is less than 50,000. So I want to find all the poor old people. So maybe I would do this. I'm going to use and because I want my return to have both of these attributes. If I use an or, I'm going to get a lot more states. I'm going to get all the states with people over 40 and all of the states with people with income under that. So you have to really think about what you want out of your data when you do these queries. And I usually have to write it out. I have to kind of think about what am I going to get as a return, what am I leaving behind, and just kind of make sure that's what I want to do. The not is a way to get almost the same thing as just that, but it's like a subtraction or an exclusion. And this gets really tricky depending on whether you're using a shapefile or data in a geodatabase. These operators work entirely differently, so probably beyond what we need to do for this. Okay. So that's all the querying stuff, and you'll do a location query, and then you'll do some attribute queries, and then you've got to go in through creating kind of your buffers and your other features to look at the data or to isolate the data. So here was a buffer. So I created a polygon around each of those 4 schools, okay? And this would have worked whether if I export the schools as a new feature and select that as my buffer, or if I had just had those 4 schools selected out of the whole data set, only those 4 would be buffered. So whatever's selected, the action happens on just those selected records. So one of the things sometimes will happen is that somebody will want all of the schools in Lane County, and they'll want to export them, and they accidentally have one little school selected that they don't notice is selected, and they'll click the file and say export, and they wonder why they only have one school in their return. So you've got to make sure that if you want everything, you hit that clear selection, okay? And you'll run into that, and you'll go, what the heck, and then you'll figure it out, okay? This is, well, I guess it's not recent anymore. The use of buffers is often shown to show the spatial relationship. So here was the one in Fukushima, which showed the buffers, the spatial buffers at 20 kilometers, 30 kilometers, and 80 kilometers, and expanding as a warning, right? So we see these a lot, and that's a pretty effective tool. You know, it's not taking into account wind speed, it's not taking into account orographic effects of mountains, but it's giving you a generalized idea, right, of where that danger zone is. Here is a really bad use of buffers. This is really not useful. I don't know. I don't know why they used a buffer. You know, it doesn't tell me that the buffer is the danger zone, the water contamination zone. If they just want to show nuclear plants, just a dot would work better, right? I mean, if I want to know just what's in service and out service, or non-service, decommissioned, just because you can buffer doesn't mean that you should, okay? So buffers, they're a lot of fun. You can do them along a line, so along a river, you can do them along a road, you can do them around a polygon. So if you wanted, one of the things that they did with a buffer in Eugene was they were trying to give tickets. Apparently, if you sell drugs within so many feet of a school, there's a higher crime than if you're outside the drug zone. And so what they had been doing was, here's the school, and they were creating a buffer. And so people would stand right there and be outside the buffer, and so they would get a low crime fine. So one of the GIS analysts, that he was just a lovely man and passed away a couple years ago, he said, well, why aren't we doing a buffer from the edge of the school? No, I'm sorry, I have it backwards. So they were doing a buffer from the middle of the school. They would put a point here, and then the guy would be here, and he would be safe. And he said, why are we doing a buffer from the middle of the school? Let's do a buffer from the edge of the polygon. Took that to court, and it did it, you know, and it's like, okay. So you can create buffers around a point. You can create a buffer along the edges of a polygon as well. So they're very versatile. And you can set your difference, and you can set nested buffers. The other thing you can do is a dissolve. So, and a dissolve is one of the options in a buffer. If you have this thing, one of the things they could have done is dissolved all of those reds, so this would have just been kind of a figure eight-ish kind of thing. It may have simplified it, but I think it was a bad design. So let's say you have all of those vegetation layers, and this is what happened kind of in the vegetation data that you looked at. You had several polygons that were adjacent to each other that were the same type of data. So if you map that, you get all these lines, and it gets kind of messy, right? It gets harder to see what's inside the polygon. So you can do a dissolve feature that says, if these are adjacent types, dissolve them into one polygon, right? So that really simplifies them from 1, 2, 3, 4, 5, 6. Instead of 9 records, I now have 3, right? And you can dissolve them based on whatever attribute field you want. So if it were land ownership, you could dissolve it on that. If it were vegetation type, you could dissolve it on that. So this is my input feature, and then I get a whole new feature or shape file with my dissolved polygons. Okay. There's overlay features, and this is a little bit like clip, but it's called an intersect. And an intersect takes two layers, and it only keeps the layers that are contiguous. That may not be the right, co-occurring, okay? So it drops off this data, and it drops off everything outside that data. What it keeps is the attributes from both data layers, right? So if this is land ownership and this is zoning, would they be different things? They might not be different things. They could be different things. I now have a feature that shows me land ownership and zoning of just my overlapping areas. Okay. So what I did with that was I took the census data that covered the whole state, and then I took a buffer and I did an intersect. And what that gave me was the school name that the buffer is associated with, and it gave me all of the census data that underlaid that buffer, right? So now I have a new feature that lets me summarize all of this information that's associated with each specific school. And Eric, I picked those schools so they wouldn't overlap, because I didn't want to deal with that one on this, okay? So that's one of the things you're going to do today. You can also do this with a clip, right? The clip is the buffer around the school, and if I clip it, I'm not going to get the name of the school. All I'm going to get is the census data in that area, okay? So again, it depends on what information you want to keep. This is small enough that if I don't, I can find the name of that school pretty easy from my point file. The other geoprocessing is called a union, and the union keeps everything, right? So instead of my land ownership and my zoning and just ending up with these two small polygons, I'm now going to end up with 1, 2, 3, 4, 5 polygons. This one won't have any zoning information. It will say null in those attribute tables. This one won't have any land use information. That will say null, okay? So again, sometimes you need it all, but sometimes you don't. One that's really useful is the erase. So it's kind of the opposite of a clip. It kind of takes everything that's overlapping and makes it disappear. And we've had to use that a couple times when we wanted to get rid of a border of something or the edge of something. So just kind of know that that's available with that erase feature. And let's see, there's the ugly. And it's not, the colors work, right? So light green to dark blue is within that continuous frame. 4 miles, I'd have gone to 2.5 or 5. They've got the name of the school, cute little school icon. The roads are a little distracting on this. Yeah, title wrong there, and even I can see that one. And the other thing is, where in the heck is this? You need to say Eugene, Oregon. Every good title should say where it is, right? That is not a complete title. This one, the colors are nice. They faded those roads so they're not as overpowering. Elementary children near 4 Lane County schools. I still would have to put Oregon in there, or at least put an Oregon inset. Not too shabby. Okay. So kind of what you're going to go through is select by location and export that to a new file. Select by attribute, export that to a new file. Create a buffer. Oh, you're going to do 2 select by attributes, right? So you're going to have 2 more files. You're going to create a buffer, which is a new file. You're going to clip or intersect, which is a new file. And then you're going to add some fields and features to your data and then summarize your data. So that's kind of the steps you're going to go through in this lab. And then there is a huge, 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 huge problem with this lab. And I just invite you to figure it out. So as you're going through that, there's a major, major theoretical assumption, okay? And some of you will get there, and then some of you will hit yourself on the head when we talk about it on Tuesday. But you're still going to go through the process of this to do the lab. Okay, so let us just take a look at what kinds of things on the lab you need. Yes, Mort.